In this video, we are going to discuss pocketing parameters in detail. So once click the pocketing parameters, right click. So now the pocketing parameters are displayed here. So input, first input. So in the input you have two options are there. One is complete, another one simple. First we'll see the simple strategy. So in the what is the difference between complete and simple? So in simple, you are going to define length and width of the pocket and then corner radius and then very basic parameters you are defining in the simple. In the complete, you have additional parameters. For example, you can rotate the pocket and then you can give the reference point and then you can do the complete machining and pre-machining also. We'll discuss in detail in the next video. So select simple. So these are the parameters are available in the simple cycle. So RP, what is RP? RP is called retraction plane. So the tool moves from the safe position and then approach to safe position in rapidly from the RP. And then once the cycle is completed, again the tool moves to retraction plane and moves to another location. So RP is the retraction plane. And then milling direction. So here you can two directions are there, upcut and downcut. Climb milling, it's similar to climb milling and conventional milling. So you can select any one of the things based on your requirement. And then F is the field rate for a pocketing operation in XY direction. And then next strategy is called machining. So in the machining you have a four types available. So single triangle always roughing operation, and then three triangles always for a finishing operation, and then in the finishing you have a wall. So wall also available. So you can finish the wall of the pocket separately, and then chamfer. So after completing complete finishing operation, you can do the edge rounding using a chamfer option. So single triangle is roughing, three triangles for finishing, so wall finishing, and then chamfering for a corner rounding operation. And then next parameter x, y, z, z0. So in the simple operation, always pocket center is the reference. X and y is the center of the pocket we are defining here. And then z0 is the top surface or where the cycle you want to start. That is the z0. And then w is the width of the pocket, and then L is the length of the pocket. So it should be a absolute value. It should be a no negative values here. And then R is the corner radius of the pocket. So always the pocket will be radius will be equal to the radius of the tool. So should be equal to the radius or maximum you can give. And then Z1 is the pocket depth, total pocket depth. You can give in absolute also you can give in incremental also. And then dxy is nothing but after every pass the cutter will be shifted to another place. So the shift percentage of the cutter shift percentage. So there will be two options. You can give incremental or percentage of the cutter. So this is the 60 percentage of the cutter diameter. This is you can give the for example if I give 5 millimeter, for example cutter is 10 millimeter. If I give 5 means it's a 50 percentage. So 5 mm will be shifted. And then dz is the depth of cut for each pass. So and then uxy is the finishing allowance for the wall, and then uz is the finishing allowance for the pocket base. And then vertical, next stage is a vertical insertion strategy, pre-drilled. What is pre-drill? Already if there is hole in the center, so the tool directly will inserted in the drill hole and then it will start the pocketing operation. That's called pre-drill. Vertical. So vertical, in the vertical strategy, this will be a solid and then tool will plunge in the plunging feed rate what we are defining here, and then it will start the pocketing operation. The next one is helical. Helical also it will similar to vertical, but it will move in the helical path. You need to define helical radius and then helical distance. So you have to define the pitch and then radius also. And then the final one is oscillation. It's similar to ramp. You need to define the angle to define the oscillation. So this helical and oscillation can be used to reduce the load of the cutter, and then vertical is a commonly used strategy. So once if you enter all the parameters, you can select accept, and then the next finishing cycle you need to select 3 triangles, and then for wall you have to select this, and then chamfer you need to select this. So these are the parameters used in the rectangle pocketing cycle. The same parameters will be for a circular also. We'll discuss in detail. In the next video we are going to see complete option, what are the parameters used in the cycle. Thank you for watching.